So this presentation, Portable Fire Extinguisher Dry Chemical Study, is being presented by Grant Lobdell, and I'm the General Manager over at Dyne Fire Protection Lab. So who is Dyne? Dyne Fire Protection Labs is an ISO 9001 certified and ISO 17025 accredited testing laboratory that specializes in the periodic testing of various fire protection products, such as firefighting foam, antifreeze solutions, fire sprinklers, and dry chemical agents. The subject of today's presentation. Our services are geared to helping contractors and building owners satisfy various inspection, testing, and maintenance requirements. Before moving on, note that any interpretation of an NFPA standard made during this presentation, and I will be mentioning NFPA 10, shall not be considered the official position of NFPA or any of its committees, and shall not be considered to be nor relied upon as a formal interpretation. For formal interpretation, I'd have you head to nfpa.org. So this study began with Fire Technology Innovations, or FTI, asking us the following questions. Are portable fire extinguishers really being recharged with the correct dry chemical agent according to NFPA 10? To answer this question, FTI had 100 previously recharged ABC portable fire extinguishers pulled from service and sampled the dry chemical agent found within them. FTI then contracted Dyne to perform the analysis on the agent they had collected. So FTI has indicated the samples, which are shown on screen in the condition they were received by Dyne, were pulled from 80 different organizations from several different industries. In total, FTI has also indicated 50 different fire extinguisher service providers were responsible for recharging the extinguishers they had sampled. 9 different extinguisher brands are represented in the study. Because Dyne was not directly involved with the collection of these samples, any sample-related questions should be directed to Mike Friedman, the Managing Director at Fire Technology Innovations. So what does NFPA 10 actually state? Well, NFPA 10 states that only those agents specified on the nameplate or agents proven to have equal chemical composition, physical characteristics, and fire extinguishing capabilities shall be used as recharge agents. Note that because Dyne does not have the facilities for determining the fire extinguishing capabilities, this study only included an assessment of the chemical composition and physical characteristics. So how did we do this? Well, Dyne used ion chromatography and various titration techniques to determine the chemical composition, and a row tap sieve shaker to determine the particle size distribution of the agent. The particle size distribution being a physical characteristic and the only characteristic analyzed as part of this study. So how do these work? Well, ion chromatography, just to give you a brief overview of that, let's say I take ammonium phosphate or ammonium sulfate and I put them into solution. Those are ionic compounds, meaning the ammonium and the phosphate are going to separate into ions in solution. They're going to be separate. Same thing with the ammonium and sulfate. Well, if I take that solution and I run it through a column, which is just a tube filled with kind of beads of different material. If I run it through this column, well, those ions are going to be attracted to that material slightly differently. And as they run through it, one of them is going to travel faster than the other. And all of a sudden, well, now you can see I've separated them out. As they drop out of the other end of the column, now I have all my phosphate, I have all my sulfate isolated, and I can quantify it. Regarding the titration techniques used, carbonate, we chose to just do an acid-base titration. So carbonate being basic, if it is in solution, I can add an amount of acid. We used hydrochloric acid to neutralize it. And how much acid it took to neutralize it, that's related to how much carbonate I had to begin with. And we'll discuss it later. We also analyzed quantitatively the amount of moisture in the sample, and we used the Carl Fisher titration to do that. So we had dry air pumped over a dry chemical agent, which is also heated, forcing the moisture into that dry air, which was collected in a vessel where a reaction happens, and we can monitor how much moisture there is. So that's, again, very brief overview of the chemical composition analysis. Just a brief overview of the physical characteristic we analyzed, the particle size distribution. Again, I mentioned we used a row tap sieve shaker in this instance. And again, the sieve shaker, this kind of technique is very prevalent in the industry. We take an amount of dry chemical agent, we place it on top of a nest of sieves. Each of these sieves gets finer and finer. The openings inside them get smaller and smaller. So as it shakes it and as it taps this nest of sieves, the agent, if it can, is forced through the sieve, and then I'm left with a nice distribution. I can mass each sieve and tell you I have X% greater than Y microns. That's typically how the particle size would be talked about. Let's get into then the requirements. We've analyzed the agent. Well, what do we compare it to? Is this equivalent? Is it not? So while we did find some manufacturers disclosed chemical composition and physical property specifications right on their technical data sheets, and a good example of this is shown on screen. Most manufacturers do not disclose this information so readily. What's more, the results of the test conducted by UL as part of the listing, UL 299, that information is also obviously not disclosed to the public either. So therefore, we were left with obtaining new virgin agent samples ourselves and analyzing them as well. So the field samples were contained to the new virgin agent samples we analyzed. So any sample that was allowed to deviate more than ISO 7202, which is a dry chemical standard that establishes acceptable deviations in these compositions or physical characteristics, was deemed non-equivalent. So again, I compare my field sample results to the result I got for the virgin agent, the new agent I obtained, and I allow it to vary a certain amount based on what ISO 7202 established. So as an example of this, let's take a virgin agent. The manufacturer says they have 90% MAP, and I too found that, yep, it has 90% MAP, monoammonium phosphate. So ISO 7202 says that, well, you can vary at that concentration plus or minus 3%. So I have my field sample, and I find that it has anywhere from 87 to 93%. I deem that equivalent to the 90% MAP product listed on the nameplate. So the requirements, those are the comparisons made, how we analyzed and made those comparisons. So regarding the results now, regarding the chemical composition results, 99% of the samples FTI sent us had a different chemical composition than the agent listed on the nameplate. And the results we found for that virgin agent. 87%, almost 9 out of every 10, had a concentration of MAP, again, the main ingredient in ABC extinguishers, that was different than the agent on the nameplate. 43% of them, almost half, had low MAP content, which obviously if you have lower MAP content than designed, you can probably expect lower performance. Also note, as part of the chemical composition analysis, I briefly mentioned it before, we quantitatively analyze the moisture content as well using that Carl Fisher titration. So this is different than just doing a drop test and more qualitatively seeing if it flows. So quantitatively, we found that 45%, almost half, had more than 0.25% moisture content. And why is that 0.25% important? Well, that's the maximum amount of moisture allowed by ISO 7202. So high moisture content obviously can lead to caking and insufficient flow and equipment corrosion. Regarding the physical characteristic results, the particle size distribution, we found that 96% of the samples had a particle size distribution that differed from the agent listed on the nameplate. 23%, or almost 1 out of every 4, had a low amount of fines, or less than 40 microns. So the Naval Research Laboratory has a great study, somewhat old but still valid, that demonstrates the importance of particle size on extinguishment performance, and particularly those fines. So in the end, all these results, not a single sample we analyzed sent to us by FTI and compared to the new virgin agent we also tested. Not a single one would have had both equal chemical composition and physical characteristics to the agent on the nameplate. So that was just a very quick, brief overview of the study, why the study occurred, what analysis techniques were used, how we compared results, how we compared the samples and the requirements, and the results of the study. So thank you for watching. If you have any questions regarding the samples represented in this study, please contact Mike Friedman, the Managing Director at Fire Technology Innovations. If you have any questions regarding the analysis, the method, or the results, please contact myself, Grant Lobdell, Dyne Fire Protection Labs.